Let's look at semiconductors. So, one of our typical semiconductors to use is silicone based. One of the reasons for using silicone is that it is a very abundant material. We have lots of it. It just needs to be purified. And that process does take quite a bit of energy and expertise, but it is helpful that we have a lot of it. Now, there is this band gap, remember from when I talked about metallic bonding, between the valence band and the conduction band. And that's why this only is a semiconductor. It doesn't always conduct electricity. There's a gap to get it up to the conduction band. Now, sometimes we would like our semiconductors to be a little easier at conducting electricity. So, what can we do? Well, this band gap is a property of silicone. So we could try to find a different substance that would have a smaller band gap, but there are properties that we like about silicone, and we may want to have different band gaps or be able to adjust how much this is. So what do we do? Well, we kind of create an alloy between the silicone and something else. It's not really an alloy because these are metalloids, but we do add in what's called a dopant, or put a little bit of something in to change the properties of just the silicone. Now there's two main types that we could do. There's the type that adds additional electrons into the mixture, and that's called the N type because it's so-called negative type. And then there's also the positive type, or P type, which adds in less electrons. So how do we do that? And what does that do to our conduction band, or our diagram here? So here's our conduction band, and here's our valence band. Same as before, but in this case we're going to take and have some silicone, and we're going to add in some phosphorus. Now, phosphorus has 5 valence electrons. Silicone has 4. So we have one more valence electron. And it turns out that those valence electrons sit in a little band much, much closer to the conduction band. So it's a lot easier to get this material to conduct electricity because we have electrons very close to where they need to be in the conduction band. This is called an N type. So N type adds additional electrons, which is negative, so that's how I remember what's N type and what's P type. Now, there's N type, and what's P type look like? Yes, P type. So we still have our conduction band up here. We still have our valence band down here. But if we take silicone and add an element that has one less electron to it, such as gallium, this only has 3 valence electrons where silicone has 4. We'll make P type silicone, and there will be some donor levels right here that will have holes, little positive charges. Holes are just where electrons could be, but they're not. And that's because the gallium has 1 less. So it's a lot easier to get an electron up into this level from our silicone, and then we can conduct electricity that way. Both of these types are more conductive than the original. but we can use their different properties to um, make electronic devices, such as cell phones or computer chips, camera, sensors, things like that. And so these are quite useful. We also end up using semiconductors in a lot of different areas, such as light emitting diodes or LEDs. Those use semiconductors as well. And the band gap will dictate what color the LED will be. So, for example, if we have an aluminum and arsenic combination, we can make orange light. But if we use gallium and arsenic, it's a little bit closer together in band, that will make infrared light. So sometimes these are used in remote controls so that you can send an infrared signal into the TV. And they're also used in sensors that will detect that light so that you can receive the signal. So these are some of the uses for semiconductors. There are so many more, and you would have to really dive in to see how N-type and how P-type semiconductors are used. But the basic understanding is that we have this band gap, and we can modify the band gap by adding dopants. We can dope in either to make an N-type or a P-type, depending on if we have more valence electrons or less valence electrons. And both of these will have their own unique properties that we can take advantage of to make devices.